Thank you for joining us today. It is so great to see participants from all around the world and from a variety of industries. Today we're launching this fascinating thin and flexible product. The product is composed of a material that harvests lights and generates electricity. The electricity can be used to power sensors and small electronic devices. It has been optimized to harvest the energy indoors, so therefore we call it a light cell rather than a solar cell. We are very proud of have taken more than 25 years of research into this product. And what makes it even better is that we have developed a production process scalable into large volumes. These together makes Epishine one of the global leading actors within printed organic solar cells. Welcome to this event and joining us today. It's an historic day for Epishine. If you have any questions, please feel free to use the Zoom chat and we will be happy to answer as many questions as possible. So let's get started.
Why is it important with solar cells optimized for indoor lighting? This is related to the intense global digital transformation that has only begun. We foresee a rapidly growing data flow between the physical and digital worlds, over time depending on a countless number of small battery-powered sensors and displays. Here interests have already clashed. More and more companies say, we really want that and need that data, but we cannot replace tens of thousands of batteries. It's too costly. It's neither practical nor sustainable. So a change in how we power small electronics could have a huge impact. This is why energy harvesting is a new prioritized topic in the electronics industry. Energy harvesting refers to technologies that help electronic devices to harvest energy from the surrounding environment. The natural energy that can be used by such technologies are heat, vibrations, radio waves, or of course light. Most of the electronics that could benefit from energy harvesting do not have access to strong heat or strong vibrations. The general available 4G, Wi-Fi and other radio waves have very little energy. So most indoor electronics really only have the limited indirect sunlight and lighting from low energy lamps to harvest. And it is exactly this kind of ambient lighting that Epishine's light cells are optimized to harvest.
This is it, our revolutionary thin and flexible light cell. It's optimized for indoor energy harvesting, contains no toxic materials and offers high performance at low light. With this, we can now offer a product that completely redefines the possibilities for anyone developing low power connectivity electronics. For instance, for the growing IoT and PropTech markets, you can now develop products where batteries won't have to be replaced. In the past year, several customers, some of which you will hear from here later today, have tested our light cells. Their main focus has been to reduce the cost of battery replacements. So why is the issue of battery replacement so important? Well, in this new digital world, we see a rapidly growing amount of sensors being deployed. Replacing batteries in these will create lots of extra work and use lots of disposable batteries. In, for instance, PropTech and IoT, solutions are often managed by companies, meaning that technicians are responsible for changing batteries. In this, the labor costs can be many times the cost of the devices themselves. Our light cells eliminate the need for battery replacements in more applications than has been possible before, because it combines three important aspects. We offer high performance at low light. Our thin and flexible design simplifies integration and allows for more area to be used for energy harvesting. Further enhancing on the integration possibilities, our light cells have unique radio permeability. This means that you can place a sensor antenna behind it rather than beside it.
As Anna mentioned in the introduction, the solar cell technology we work with at Epishine is organic photovoltaics. The active material in organic photovoltaics is carbon-based long molecules called polymers. These polymers can be tuned for different light spectrums. The active material in our light cells are tuned and optimized to match the visible part of the light spectrum, which is then the dominant illumination source for indoor applications, typically LED-based or fluorescent illumination. The reason organic photovoltaics is ideal for indoor light energy harvesting is because it has proven a high power conversion efficiency without containing any highly toxic materials. You see here a publication from Nature Energy showing a recent work using so-called non-fullerene acceptors, where you see a very high power conversion efficiency both at 500 and 1000 lux. Power conversion efficiencies of 26%, and this is in parity with gallium arsenide, standard high-performance solar cell technology commonly used for drones and space applications. Organic solar cells and light cells are manufactured using printing and roll-to-roll processes, something like quite similar to how you print newspapers. However, the active layer absorbing the light is very thin, usually around 100 nanometer, which is 1000 as thin compared to a human hair. This allows for a very efficient material use, but comes with a drawback that it's a high risk that we get contact between the top and the bottom electrodes. Commonly, organic solar cells or light cells are printed using a sequential method where each layer is deposited on top of each other. However, even small micro defects in the process can then lead to local micro dewettings that in turn makes contact between the top and the bottom electrode, leading to short circuits. This is detrimental for the performance of the device. At Epishine, we have developed a method to manufacture organic solar cells using lamination. Instead of the sequential printing, we print one half of the light cell on one substrate, the other half on another substrate, and then we use heat and pressure to laminate these two together. And this way we can completely then avoid and eliminate any shunts, and thereby allow for a high yield and high performance also at very low light intensities. Within the segments we currently target, the luminance commonly varies somewhere between 20 and 1000 lux. This depends very much on the spatial position within the room, the time of the day, whether lights are on and not on, and also sometimes the season if we get stray light from windows, etc. What is critical for large-scale deployment of light energy harvesting is a high uptime. Therefore, it's also very important to be able to handle the lower light corner cases that can occur. Typically in an office you have somewhere between 100 and 500 lux on the walls, while there can be corner cases down to 50 lux or even lower. This is also especially true for the home segment, where the light intensity during periods of the year can go well below 50 lux also. Here we see a perfect match between the production methods for large-scale production of organic light cells that we have developed at Epishine, where our modules can then maintain performance down well below 50 lux to meet the entire range of applications between 20 and 1000 lux that will be necessary to enable light energy harvesting.
How does it look like when designing products using light energy harvesting? This product is one of the first prototypes we did together with our customer. It's a temperature and humidity sensor that uses a supercap and our light cell. In this case, the active area of the cell is fully exposed to achieve maximum performance. Looking at our own 3D printed demos, we have tested different diffuser materials in case the customer wants to hide the cell. By using an extra sheet below the diffuser, we can achieve a uniform look of the product. Since our cell is very thin and flexible, it makes it very adaptable when integrating in different kinds of products. Here we can see a fire detector using 4 of our light cells that are mounted inside of a cylinder. The cell has a minimum bending radius of 10 millimeters, so it can be used in even slimmer and smaller products than this. When it comes to contacting the module in a product, there are different ways of doing it. In this image we can see a basic stack-up where the cell is laminated to a plastic cover and then attached to the backside of the PCB. The Nicomatic contacts can then bend around the PCB and be welded in place. Variations of this can be used, such as fitting them through holes, soldered flat, or using spring contacts. One of the main benefits with our modules is that we can adapt the cell to fit a specific part of a product. As seen in this picture, we have a custom cell with cutouts so it would fit the customer's original part. You will hear more examples from our customers later in this presentation.
How can we support you with the electronics development of your light-driven product? For this we have a number of tools. First and foremost, how much lux is available in your environment. With this lux logger, we can record how much light level is available in your environment, and we can use that data to estimate how much energy you can expect to harvest. All of the information needed to do that calculation is available on our data sheet, which you can find on our webpage. Next, we have this evaluation board, which consists of a module, some electronics, and a storage medium. And this one you can use to collect to your prototype or your existing product and evaluate how much energy is harvested. Finally, we have a number of reference designs, both mechanically and electronically, that is tailored to different needs, such as what type of storage medium to use and how big that storage medium could be. Expertise in industrial design, mechanics and electronics is at the heart of what we do at Epishine Solutions team, and we're happy to support in any way we can.
Now we have the opportunity to hear from some of our early customers who will be sharing their experience of using our light cell. These customers believe that this is the right technology for the future and would like to be first on the market. It is very valuable for us to have this close collaboration with these customers. I would like to first introduce to you Per Melin from Pollux.
Hi, my name is Per Melin. I'm the founder, together with 5 more people, of Pollux. We have for the last 2 years focused on energy harvesting products. Roughly a year ago, we have a cooperation with Epishine, which is the prime solar energy harvesting company in Scandinavia. And we have founded a certain relation with them where we in Pollux use their products to actually transform the battery-free life into real product that can be applied in industry or consumerly. Epishine is providing us with solar cell panel that make it possible to do energy harvesting in very low lighting level. One typical application is for sensor data, where we collect temperature or humidity or air quality data for a building. So presently we are in discussion with about 10 different bigger real estate and facility management company. One of the benefits is of course that you will become sustainable and more environmental friendly, but one of the main issues for companies is also beneficial of lower cost. You don't have any operational cost for changing batteries. This is the very first battery-free working sensors for facility management. It's called Haber. It has no battery and a solar cell, and it's available on the market as we speak. Please contact us if you have any questions or ideas that you'd like to explore. Let's talk.
Hi, I'm Andres Gomez. I'm a research engineer at Miromico AG in Zurich, Switzerland. I have been working with Epishine since 2019, developing our latest product called the Mito Card. Here is the Mito Card. It's an ultra-thin smart card that is powered not by batteries, but by light. You can see Epishine's product here on the top, and on the bottom, you can see our electronics, which include a few environmental sensors, as well as a wireless radio. This card has Bluetooth, so it can communicate with smart infrastructure to authenticate users and estimate the occupancy of indoor environments. It can also be used for environmental sensing for variables such as temperature and humidity. We will start field trials with this new product in mid-February. Epishine solar cell is one of the key components in this design for several reasons. First, it's ultra thin and it's also flexible, which is what allows us to have such a small form factor. As you can see, it's smaller than a credit card. But it's also highly efficient. So whenever I'm indoors, I can just take this out of my pocket, and it only takes a few seconds for this device to turn on and start communicating wirelessly, even though it has no batteries. Epishine's product is really one of the key integrators that allowed this design to be feasible. We think that Epishine's technology has a bright future ahead of it, and we're very happy to be a part of it.
Microdata 2 is specialized in designing fire detection systems for demanding applications such as cruise and naval vessels. Know-how, reliability and support are the key factors that have made Microdata one of the market leaders. To be focused mainly in cruise and navy market means to realize the systems with more than 10,000 detectors. Due to the continuous challenge of the market, we have decided to introduce a wireless fire detection system, especially in harsh environment. One of the strictest requirements is the battery life. We must guarantee at least 3 years to respect the EN 5425. That is the European standard for wireless fire detectors. For commercial reasons, we need to increase the battery life to at least 5 years. Energy harvesting by solar cells is mandatory for the success of our application. Epishine's OPV modules are helping us to reach our expectation. We are using 8-cell solar panel connected in parallel mode. By this solution, every day, we have 8 hours of autonomy by solar cells. The market possibilities for our wireless fire detection system, powered by Epishine's OPV modules, are in marine market as fire detection in temporary yards, and as fire protection of the lashing bridge of the container ships. We are defining the right size of the OPV modules in order to respect the requirements. We hope to start the certification step in Q2 2021.
Hi, my name is Hans Arnström and I'm CEO of the Stockholm-based company ACSS. We have been a supplier of electronic locks in business-to-business applications for 15 years. Our solution has always been powered by battery. Lately, more and more customers ask for a sustainable solution in aspect to the environment, as well as to eliminate time-consuming battery replacements. A solar cell harvesting indoor light was something that would meet the customer's demands. Not only would it solve a problem of existing products, but it would also put us ahead of competitors working with power by wire, as well as competitors that work with lock solutions hidden from the outside of a locker door. When we came across the Epishine solar cell, we unexpectedly saw a possibility to implement the cell in our existing products with a minimum of efforts. Our front panel could be modified for the cell, and the electronics would fit in the existing battery compartment. Making our locks front to be transparent with the cell behind made it protected, and thanks to the thin cell, it would fit without any changes of other components. Our main markets are schools, which may have around 1,000 locker locks, shopping malls for temporary use by visitor, as well as big museums and libraries. All indoor applications and traditionally supplied with batteries. We're now looking forward to become a part of a sustainable future.
Thank you, Pollux, Miro Mikko, Microdata Due and ACSS for participating with us today. It has been very interesting to hear your experience of using our product. Thank you for sharing that with us today. We see a strong growth in connected applications, and the power management needs to be solved in a sustainable way. That creates a strong traction to energy harvesting. A very interesting question is who will be first on your market with this new interesting technology?